In example 13, we're taking the log base 2 of x minus 7, which means whatever results we come up with, x has to be greater than 7. In order to approach this, we'll apply some of the properties of logarithms that we've introduced to rewrite this as the log base 2 of x minus 7 squared plus the log base 2 of 2 is equal to 3. On the left-hand side, we have two logs with the same base being added together, so we can combine that into a single logarithm as 2 times x minus 7 squared. All of that set equal to 3. Our next step, what we want to do, is rewrite both sides of this equation as an exponential expression raised to the power that we already have on each side of the equation. So this will be log base 2. Let me say it again. We're going to rewrite this as 2 raised to the log base 2 of 2 times x minus 7 squared equal to 2 to the third power. We can do this because we know these expressions we already have and the exponents are equal because they were equal in the previous step. And the reason we want to do this is because now on the left-hand side, our exponential base 2 will cancel with our log base 2, leaving us with 2 times x minus 7 squared is equal to 2 cubed, or 8 on the right-hand side. So using the fact that exponentials and logs are inverse functions of each other, we can cancel out that logarithm and now expand what we have on the left-hand side to get 2x squared minus 28x, and if we go ahead and subtract over the 8, we'll get plus, not 80, but 90 is equal to 0. From here, we would need to look at factoring, and this would factor as 2 times x minus 9 times x minus 5 is equal to 0, giving us two values for x, positive 9 and positive 5. We have that domain restriction, though, that tells us x has to be greater than 7, so that value of 5 in this case isn't a valid solution. Even though we came up with two different results for x, only one is within that restriction, so our sole solution in this case would be x equals 9. Our approach to example 14 will be similar, but now we have two different log expressions that we need to look at for the domain. X has to be greater than 0, and x plus 3 has to be greater than 0, meaning x has to be greater than negative 3. So if we take x greater than 0 as our domain restriction, that already encompasses the fact that x has to be larger than negative 3. So we just need to make sure we compare any results back to that statement. We can combine the logs that we have on the left-hand side to rewrite this as the log of x times x plus 3 is equal to 1. And then we'll use the same approach that we used before. Since in this case we have a log base 10, we'll rewrite this as 10 to the log base 10 power of x times x plus 3. And on the right-hand side, we'll write this as 10 to the first power. On the left-hand side, log base 10 and our exponential base 10 will cancel, leaving us with x times x plus 3 is equal to 10 to the first power, or just 10. Expanding out on the left-hand side and subtracting over 10 will give us x squared plus 3x minus 10 is equal to 0, or x minus 2 times x plus 5 is equal to 0. This gives us two solutions, x equals 2 and negative 5, but negative 5 isn't greater than 0, so we'll throw that value out, leaving us again with only a single solution, x equals 2.